Hi, today we're going to talk about experimental probability. But before we get into experimental probability, let's look at an introduction to probability. So, the likelihood or chance of something happening is called the probability. Probability can be written as a percentage or a decimal. Okay? An impossible event. So if something is impossible to happen, an impossible event has a 0% chance of happening and has the probability of 0. A certain event, okay? A certain event has an 100% chance of happening and has a probability of 1. So below you see that I have a number line here from 0 to 1. 0 means impossible, 1 means certain. And remember, 0 stands for 0%, 1 stands for 100%. Okay? So you know that if it's 0, it's impossible. If it's 100%, it's certain. If it's very, very close to 100, then it's very likely to happen. If it's in the middle, it has an equal chance of not happening as it will happen. And then the lower you get, the smaller the chance is that it is going to happen. All right, so let's look at experimental probability. So let's look at some vocabulary. The number of trials is the total number of times that the experiment has been conducted. Okay, or the number of times that the experiment has been performed. The outcomes are the different possible results that you can get in one trial of the experiment. So the different amount of combinations. Then you have that the frequency, okay? And when we say frequency, remember frequency we count. So the frequency of a particular outcome is the number of times that the outcome occurs. And then we have the experimental probability, which in other words is the relative frequency. Okay, that's the same thing as saying the relative frequency of an outcome is the frequency of that outcome expressed as a fraction or percentage of the total number of trials. So let's look at an example here. When a small plastic cone was tossed into the air 250 times, it fell on its side 167 times, and then it fell on its base 96 times. So identify the following. So it says, what is the number of trials? Remember, the number of trials is the total number of times the experiment was performed. So that will be 250. The outcomes of you tossing the cone will mean either that it's going to land on the side or it's going to land on the base. Okay? The frequency of the times that it landed on the side, or the number of times that it landed on its side, was 167 times. The frequency of the number of times it landed on its base was 96 times. So now when it says the relative frequency of the side, what that means is that you want to find the percentage or the experimental probability, or just the probability that is going to land on a side. So it landed on a side 167 times out of 250 times. So we can express this as a simplified fraction, or we can express it as a decimal or percentage. So we will have 167 over 250, or you could put it as 0.668, or, and I'm going to put the equal sign here because these are equivalent to each other. And if we have this in percentage form, This is approximately 66.8%. Okay, so you can put it as a fraction, a decimal, or a percentage. It does not matter. Okay. So now let's look at the relative frequency of landing on the base. So it lands on the base 96 times, 96 out of 250. 96 out of 250, you can put it as a simplified fraction if you want. That's going to be equal to 0.384, which is equal to 38.4%. All right, so let's talk about two-way tables. So two-way tables are tables which compare two or more categorical variables. So let's look at example 1. So it says, hospital employees are asked to take a survey on which mode of transportation they used in order to commute to work. A summary of their responses are below. Use the table to find the number of employees who, A, take the bus. So the number of people who take the bus, there are 9 males and 14 females. And we know that 9 plus 14 is equal to 23. We want to then find the number of employees who are female. So there are 38 females who ride in the car, 4 females who take the light rail, and 14 females that take the bus. So if I add all of them up, 38 plus 4 plus 14 is equal to 56. So there are 56 females who took this survey. All right. So the next one, we want to figure out how many employees are male and ride the light rail. So they have to be male and ride the light rail. So that is 11. Part D says we want to figure out the number of employees who took the survey. So that means I need to add up all the numbers in the table in the different categories. So when I add up all of my numbers, I end up getting 105 people who took the survey. Part E says had four-wheel transportation. So four-wheel transportation. So the cars are the only thing that has 4 wheels. So that's 29 plus 38. And 29 plus 38 is 67. All right. And then the next one, it says we need to find the number of people who are female and travel by car. So the females that travel by car is 38. Or you can travel by light rail, no matter if you're male or female, which is 11 and 4. So if I do 38 plus 11 plus 4, that is going to be equal to 53. All right, so now example number 2 states that the results of a survey of how many juniors and seniors have attended prom or not are shown below. Use this table to estimate the probability that a randomly selected person, A, is a senior. So before we can find the probability, the one thing you need to understand is that we do not have our total values. So remember, your probability is the chance of something happening or the number of ways that something can happen divided by the total amount that you have. So I'm going to put my total row and my total columns in, and I am going to go and add. So 32 plus 56 is 88. 98 plus 41 is 139. 32 plus 98 is 130. 56 plus 41 is 97. And then to find my grand total, I can do 130 plus 97, which is 227, or you can do 88 plus 139, which is also 227 as your overall total. So now let's find the probabilities. So we're going to find, the first part says, find the probability that the person selected, the randomly selected person was a senior. So you had 98 seniors who went to the prom, 41 who did not. So if I do 98 plus 41, that is 139 seniors total. So that's 139 out of 227. So when I do divided by 227, I end up getting that this is approximately 0.612, the decimal, which equates to 61.2%. The next thing that we want to find out is the probability that the person that's selected is going to be your junior that also went to the prom. So the junior that went to the prom is 32. So this will be 32 out of 227. And if we do 32 out of 227, that is approximately 0.141, or you can express it as a percentage as 14.1%. Part C says that we want to find the probability that the person was a senior or they went to the prom. So the number of seniors was 98 and 41, okay? Or they could go to the prom. So the number of people who went to the prom was the 98 seniors and the juniors, which was 32. So if I add them all up, I will have 32 plus 98 plus 41. And I would get 171. So that would be 171 divided by 227, which is approximately 0.753, which is approximately 75.3%. And another way that you could have gotten 171 is you could have added up the number of seniors total, which was 139. And then you could have added up the total amount of people who went to the prom, which was 130. But you would have to realize that the 139 and the 130, you would be counting 98 twice. So we would have to subtract those 98 seniors because they're represented twice. And you would have seen it would be in 171. Okay, so if you wanted to do it like that, you could have too. All right, and last but not least, D, it says, is a senior and didn't go to the prom. So the seniors who didn't go to the prom it was 41 of them. And then you can say, or you can be a junior and went to the prom. So that was 32. So that was 41 plus 32, which is equal to 73. And 73 out of 227 people, it would have been 0.322, which is approximately 32.2%. All right. If you have any questions on experimental probability or two-way tables, please let me know. And you have a great day.